Factoring out a greatest common factor. Remember the distributive property. We used it a little bit in the last section. We use it to distribute a term that's multiplied by a sum, like this 3. We multiply like this. That's the distributive property. And you end up with like 3 times 2 plus 3 times x. Okay, and then you would have 6 plus 3x. Now we're going to go in the opposite order, so we're going to start with something like this, 6 plus 3x, and we want to go in the opposite direction and end up with 3 times 2 plus x. So it's the opposite thing that we're doing when we distribute. And we call it factoring, and it's writing your expression as a product of factors. And the simplest factoring that we can do is factoring out a greatest common factor. And the greatest common factor is the largest term that will go evenly into each term of the polynomial. So to be in a factored form, it has to be a product of factors, which would be this. And it gives you another way to write your expression. It's equivalent to the original problem. So if you do distribute and multiply out, you can check yourself. You should end up with what you started with. And it lets you solve quadratic equations by factoring in the future. That's what we're going to do soon. So the first thing you want to do is figure out what is the greatest common factor, if there is one. Sometimes there's not. On this lesson, of course, there will be. Divide the greatest common factor out of every term in your polynomial, and then use the distributive property to check yourself. And there's the list of steps right there. So I'm looking at 8x squared minus 6x. Now I can go ahead and write all the factors of 8. So like 2 times 4, make a tree here, 2 times 2. And then the factors of 6, which are 2 times 3. And then what I'm doing are looking at the 2 trees and seeing what's the same on any of them. And I see that I have a 2 on both, but only a single 2 because the 6 only has 1 2 as a factor. So since there's only 1 2, then my greatest common factor is going to have a 2 in it. And then I want to look at the x's because I have variables, and this x means x times x, of course, and this x is just a single x. And again, look at those lists, and I see that I have an x on both lists, but I don't have 2 x's on both, so I can use one x, a single x, as my greatest common factor. So my greatest common factor now looks like it should be 2x. So what I want to do is write 2x times something that's going to be equivalent to my original polynomial. So what I want to do is, you can do it mentally if that's working for you, or you can think about each term, 8x squared divided by 2x, and then minus 6x divided by 2x, and simply reduce each of them, which is what we're doing if we do it mentally. And the 2 goes into the 8 4 times, the x goes into the x squared, and we have an x left over. And then the 2 goes into the 6 3 times, and the x's, it's x over itself, reduces completely. And so my result will be that 4x minus 3 for inside of my parentheses. So that is my factored form of this first polynomial. And the check part is extremely important because it helps me see if I missed anything or if I messed up any signs. So I want to just distribute that 2x. So I say 2x times 4x. So I have 8, because the 2 times 4, and then x times x gives me x squared. And then 2x times negative 3. So I have negative 6. That's for the 2 times negative 3. And then x, there's not another x to multiply by, so 8x squared minus 6x. And that looks like it's exactly like what we started with. So I know this factored form is equivalent to what I started with. I'm not guaranteed that it's completely factored, but I think it is, because when I look at my solution or my factored form, the 4 and the 3 don't still have greatest common factors, so I'm pretty sure I've finished that one. And there's not an x squared, so I can't factor anything else out in terms of the variables. Okay, when the lead coefficient, that's the number part of the highest term, so the variable with the highest exponent, when it's negative, see if I can get back up to that note, we generally will factor out a greatest common factor. of a negative greatest common factor. So in this case, I have negative 6x squared plus 2x minus 4. And what we're saying is that we'd like for our greatest common factor to have the negative on it because the x squared has a negative. So I'm looking at the factors of 6. It's 2 and 3. Factors of 2, obviously just 2. And the factors of 4, 2 and 2. And whatever I have for my greatest common factor has to be on every single list. So I see that I have a 2, just a single 2 that's on every single list. So I know I'm going to have a negative 2 as my greatest common factor. And now I want to look at the variables. And I look through the variables. I have an x squared, an x, and then no variables. So that tells me that there's not a variable that I can divide off of every term and still have non-fractions as a result. So negative 2 is all I've got for my greatest common factor. So again, I want to think about either in your head or on your paper dividing every term by negative 2. And it might be helpful if you keep the negatives with the numerators and then just put a plus in between each term. So we're thinking about these negatives, and negative 2 goes into negative 6 a positive 3 times, because negative divided by negative is positive. And here I have negative 2 goes into positive 2 negative 1 times, because a positive divided by a negative is a positive. And then on the last one, I have a negative 2 goes into negative 4 a positive 2 times. So I'll put those signs on there just so we're careful about that. Now I didn't have an x in there at all, so I have things as reduced as they can be. Remember, I factored out a negative 2, so that comes out to the front. And then I have 3x squared, and then I have negative x. I don't have to put the 1 in front. It's considered more simplified by leaving off the 1, and then plus 2 on the end. Okay, that's my factored form. And double check your signs because I factored out a negative. So I have negative, positive, negative, and now it became positive, negative, positive. So all the signs flipped. That makes sense. So I have negative 2, 3x squared minus x plus 2. And I want to distribute that and check myself. And especially when I factor a negative out, because those are so easy to make mistakes on. So I have negative times positive, so a negative 6x squared, and then negative times negative, so a positive 2x, negative times positive, so a negative 4. And so negative 6x squared plus 2x minus 4. And that comes out exactly as the original. So I know that I got all my signs right, and that what I have in my factored form is equivalent to what I started with. Number 3. Here I have something unusual, but I see that this x plus 2 is my greatest common factor. So I have an x plus 2 on both, and I'm going to pull that out as my greatest common factor. So I have an x plus 2, and what I have left is going to be everything else, the x minus 4. Now I want to show you that one more way, because if I decide that my greatest common factor is that x plus 2, what I was showing you before will still work. So we have x times quantity x plus 2 divided by that x plus 2, and then plus negative 4 times the quantity x plus 2 divided by x plus 2. Those factor, the x plus 2 factors reduce, and all I've got left is the x minus 4 as your remaining factor. And then the part I factored out, remember the x plus 2 goes out front. So to check that, here's my factored form here. I have x plus 2, x minus 4, and I'm going to do it not using FOIL, which you might remember, but thinking about this whole first factor as just a term, because I want to get it back to what I started with. So I'm going to take that and distribute it onto each of the terms in the second polynomial. And you can do this anytime you want to distribute, and then just do another distribution if you need to get it further, and I'll show you that way again. So x plus 2 distributed, so that's going to be an x times x plus 2. That's for the first term, and then a minus 4 times x plus 2, that's for the second term. And that comes out exactly like what we started with.